All right, let's go ahead and let's get started. Welcome everyone to our second official ArcGIS Indoors webinar in our webinar series, ArcGIS Indoors and Indoor Positioning. This this webinar will be recorded, so if you have to leave early, that's totally cool. You'll get to see the whole thing in all its glory afterwards. So let's go ahead and get started.
Yeah, thanks everyone. And thank you all for joining our today's session. We'll hope you enjoy it. And at the end of the webinar, you will have an opportunity to ask us some questions, and we'll do our best to answer as many as possible. And with that, I'd say let's start. A little bit of an introduction. So Christian, maybe give.
So, I am Christian Tate. I am a product marketing specialist here at Esri, based in Redlands, California. I've been part of the Indoors team and project for going on almost 2 years now, so I'm excited to be here with you guys today. Go ahead, Bernd.
Thanks, Christian. Yeah, hi, I'm Bernd Guru. I've been working in tech industry for over, I would say, 10 years. I have a background in software development, started my career as a programmer and project manager in various startups. And it was around 2010, I founded a company called Indoors with a dot. And ever since then, I've been highly invested in working indoor positioning and navigational industry. And my role at Esri now is Global Market Development Manager, which means that I help groups internally and customers externally to find out how they can use this new indoor product, but also raise awareness in various industries that A, there's a new Esri product, a new cool kit on the block, as well as B, why companies benefit from using it. I do work in both Austria, Vienna, and California, so which sometimes leads to longer response times on my end. So sorry for that. If you send me an email or a message, really, please be patient with me. And with that, I'd like to introduce you now also to this new Esri R&D Center in Vienna, formerly known as Indoors. So as you know, this new Esri R&D Center is located in Indoors. It's actually my old company, Indoors, that was acquired by Esri mid-February this year. And we're here a team of about 20 professionals who have specialized in indoor positioning and navigation solutions for over 10 years. Indoors was founded, as I was saying, in 2010 with really the mission to provide the best blue dot in the world and bring the best real-time positioning into buildings. About 2/3 of our team here is made up of strong research and development force. They are dedicated to work on smart algorithms and continuously improve the technology to ensure highest quality results in positioning. That is also the main goal of this R&D center. So providing the best blue dot in the world, which sounds hopefully kind of familiar, and hasn't been that long that we here joined the big Esri family, which we are really proud to be part of. But I'm pretty sure you will soon hear more from us in the future. In our last webinar, both Will Isley and Paul Rick already introduced you into the beauty of ArcGIS Indoors, the indoor mapping system for smart operations and mobility. What you can see here is an overview of its components, if you're not familiar with it yet, and how they play into the whole world. Starting with the CAD BIM files for the map, to the Indoors Pro add-in. There's also an Indoors web and Indoors mobile component to this. And by the way, this Indoors mobile component is where their indoor positioning comes into play. For the sake of keeping this webinar not only short and crisp, but really dedicated to indoor positioning, I will not go into details on any of those other components now, but really just focus on indoor positioning. If you're interested in knowing more about the other ArcGIS Indoors components, please feel free and feel free to reach out to us by visiting the ArcGIS Indoors website, where you can find more information. But not only that, you can request there to talk to one of our experts, and they're happy to reach out to you to answer all of your questions. So now let's take a closer look at indoor positioning systems. So everyone who has joined this webinar today will probably have heard about IPS, indoor positioning, already at least once. You may have heard in the conjunction with travel or healthcare, maybe trade shows or retail, But do you know what indoor positioning actually means? So indoor positioning, which is also often referenced to as an indoor positioning system, the acronym IPS, enables exact location of people or objects inside of a building. In other words, it's like a GPS for indoor environments. But before getting too much into detail, it is important for all of us to understand how outdoor positioning works. So basically, there are two ways to figure out one's position. The first way is to compute a precise position at a given time. It's called an absolute position. On the Earth, we use longitude, latitude to describe one's position. For centuries, and this is very important to know because I will reference to this then later when talking about indoor positionings. For centuries, positioning was really a huge challenge for scientists working in the navigational field. It took a lot of time to get any results and then collect, and then the calculated position was approximate at best. So they had to use a sextant. I don't know if people know what a sextant is nowadays. I'm using one when I'm sailing, for instance, and a precise watch to determine one's position. So you can imagine these techniques could only be used under good weather conditions and at certain times of the day. Since the 70s for the military and the 80s for civilians, there has been the new cool kids on the block, a technology we now all very well know today, and it's called GPS, the Global Positioning System. The GPS uses a multi-satellite constellation for which the precise position is known, and each satellite embeds a very accurate and synchronized atomic clock. So it broadcasts a unique radio wave signal that includes a clock timestamp. So any GPS compatible device, which, I mean, let's be frank, all of us have a smartphone. So each GPS compatible device on Earth can simultaneously receive signals from several satellites, and using that really compute its own position. And this now allows us all to use Waze or Google Maps or whatever to find our, or a navigator to use on a daily basis to find our way, or the shortest way without being in too much traffic to our workplace. So this was the first way, I would say. The second one is to calculate one's position by computing speed and direction from the last known point of departure. And this method is called the relative position. So the first one was the absolute position. Now we're talking about the relative position, or dead reckoning. It usually relies on the use of gyroscopes and accelerometers to compute the distance. And this type of positioning is mostly used in situations when a continuous precise position is needed. So for instance, in ships or aircrafts or space rockets, missiles, and sometimes even cars. So that was really to give you a little bit of background before I now go into why even use an indoor position. So now, first off, why do we even need indoor position, right? It has not been around for too long, and many people are still skeptical, but more and more businesses really across different industries, such as transport, healthcare, retail, or corporate campuses are starting to acknowledge IPS, the indoor positioning, as a factor that can help improve the way they're doing businesses on a day-to-day basis. So why use IPS? Well, IPS is really part of the next wave of digitalization. Digitalization is happening now, and indoor positioning is an essential part of it. The second one is really digital, connected, and smart workplaces. This completely changes the way employees and employers interact with and interact at their workplace. So share my location or locate POIs. Where is the toilet, or where is a break room I'm looking for, or a conference room, for instance. It's also to maintain a leading edge in a competitive field. So leveraging technology is not just important for your core business, but it's also to attract young talent at the workplace. Indoor positioning can be used to optimize customer and employee satisfaction, so to provide really the best possible indoor experience and highest convenience at a workplace. Indoor positioning can be also used to improve internal workforce and operation management. One of the last, or actually two of the last one, is create a common operating picture at the workplace. So as you might have heard in other presentation, this is really a big thing for us. The next part of why to use indoor positioning is to obtain valuable positioning data. This is analytical data you can use, and analytical data that can be used to improve utilization of things, improve utilization of your workplace. And the last one is really to increase business intelligence for better planning, for reducing inefficiencies, and so on. So now with that mindset, with that knowledge already, I want to introduce you into what indoor positioning is and what indoor positioning systems there are out there. So indoor positioning, as you might know, is a very complex matter, since common outdoor technologies don't really work inside buildings. So GPS waves are unable to properly reach our devices, our mobile phones, our smartphones and tablets because of obstacles such as brick and mortar, the walls and roofs around us. Moreover, the GPS is not able to figure out on which floor the receiver is located. So even though if you might get an indoor position inside of a building, the system doesn't know if you're on floor 7 or on floor 3, which is kind of for a lot of the use cases not very functional then. Speaking about the relative positioning, so the classical dead reckoning, the usage of the smartphone sensors is also nearly impossible to use indoors due to the size and the quality of the gyroscopes in our smartphones. And since most indoor use cases more or less involve people with smartphones, this is a real technical challenge. The graph on this slide shows you which technologies are currently available on the market, or we see as majorly available on the market or upcoming on the market, and what their respective individual advantages and disadvantages are. The y-axis shows the effort and cost of a setup and of the usage. So it includes the CapEx, which includes the installation, the deployment, the hardware, and the system integration, as well as the operational expenses, the OpEx, operational costs, licenses for usage of the system, connectivity, and maintenance. On the x-axis, what you can see there is how accurate the positioning is, how accurate the positioning works. And of each of those technologies I'm going to introduce you, actually in metrics users, because it's been from Austria, it's easier for me, so sorry for that. But yeah, let's go through them into more details. And really with the first one I want to start with is GSM, so the Global System for Mobile Communications. The technology that GSM uses is triangulation, and the accuracy is not really good. So they're about 100 meters to kilometers. The pro is it's available everywhere, at least everywhere where you get cell phone coverage. The con is the telco providers might only actually use it. So where to use it is not so much the indoor spaces, but for the outdoor spaces. Or if used in an indoor case, you can use it, for instance, for emergency use cases. So if a government wants to know the NG 911 regulatory, it's where a call comes from. The next one I want to talk about is GPS. So we talked now a lot about GPS already, and GPS can be sometimes used indoors or in combination with some of the use cases. So the subtype is assisted GPS, and accuracy we're talking here about is about 3 to 100 meters. Why the 3 meters indoors? Yeah, just think about the use case, like you're inside of a building and you've got a glass roof, for instance. Then you still are able to get a position inside of a building quite accurate, but again, the floor level is not where the beauty of the system is. So the pro is it's available and it comes at no cost. The cons really are that it's, I would say, for an outdoor use case only. So where to use it outdoors and when to use it is if you want to do like an indoor-outdoor kind of combination use case. So just think about a corporate campus or something like this. We've got multiple buildings. For the indoors, where you are inside of a building, you use a real IPS, and if people then leave the building or in between those buildings, you can automatically switch to GPS to cover those areas as well and use the GPS system outdoors. The next one is Wi-Fi. And there are two different subtypes how you can use Wi-Fi. One is a fingerprinting approach, the other one is network-centric. I'm first going to start with the fingerprinting approach, which gives you an accuracy in most cases about 5 to 15 meters. The pros is, as nowadays everyone uses their phone all the time. We got, I would say, more or less Wi-Fi everywhere. So in most cases, there is no extra hardware needed, and it's kind of which results in not a lot of costs. The cons is that in order to use this technology in iOS on the Apple devices, well, Apple blocks those signals, so it blocks you access to those signals. On an Android with the latest version, it also gets kind of tricky. So the usage really is here for us, and what we see here for indoor positioning and wayfinding use cases where you've got a dedicated, like you're in iOS shop only, or you want to go in that direction. The subtype, the other subtype I was talking about was network centric. So what does that mean? The network itself, so all the access points themselves, they can be sometimes kind of smart. So what your phone does is it continuously, not only your phone, your laptop, basically all your Wi-Fi devices, it continuously sends out so-called probe packages to check which access points or which Wi-Fi is next to them. So if you've got then multiple access points and they're smart enough to talk to each other, the network itself can figure out where something is. This gives you an accuracy of 10 to 20 meters. You, most cases, need no extra hardware because you've got Wi-Fi everywhere. The cons is that you've got a very high latency, so up to 10 seconds, and it's not really accurate. So the usage of those type of systems, what we see really is like for anonymous tracking or crowd detection. So you want to know if a crowd, if they enter a shopping mall, do they first go to this store, or do they first go in this proximity of the building? So really kind of an anonymous tracking with not that high of an accuracy. The next technology we see is EMF, Earth Magnetic Field. Again, the method is a fingerprinting approach, which I'll get into details a little bit later. But what this means is you get an accuracy of 3 to 7 meters in most of the cases. The pros is you don't need the hardware because, hey, your Earth, the Earth below us, that's the beacon we use. The Earth below us is the signal propagation we use. The cons is it's not really reliable over time and maintenance intensive. I don't know if you use a sailor or a private pilot. If you are, you probably know that the Earth magnetic field constantly drifts. You've got it on charts, or if you're a sailor, each half a year you need to adapt. You need to change your maps because otherwise you'll end up in maybe a little bit of a different place that you're used to when you navigate by using a map. So the Earth magnetic field really drifts, and this means that you need to that this system is kind of maintenance intensive. Again, usage of it is indoors and for wayfinding. A technology we see upcoming is 5G. I only got it very small here because why is that? 5G, upcoming technologies. It's still not out there. I mean, we read about it probably now on a daily basis, but until we've got a distribution of 5G, this will probably take quite some time. As well as, think about it like this, the 5G is set up by telcos, so they will probably be unlikely to share this information with users, with customers, without having kind of a hefty place in this game. Usage, again, is indoors, outdoors. We see that the usage of 5G probably will go in the direction of proximity marketing and push notifications, and not so much into the wayfinding. iBeacons, Bluetooth Low Energy beacons, they're one of the most used, I would say, technologies nowadays for indoor positioning and navigation. There are two ways on how to do that. The first one is the mode of proximity. With proximity, you get an accuracy that really depends on how many beacons you set up. So this is also the pro of this system. So it's really easy to implement, and you don't need someone to serve it in the building or something. It's really low cost. So you just need to place some beacons, and that's about it, and know where those beacons are. The cons are it's not really reliable. So as people walk through a building and as beacons might get a little bit pushed to the side or something like this, the accuracy really varies. So the use case we see, or the usage we see there, is both indoors and outdoors. There are beacons you can place outdoors as well. And usage in terms of use cases is really proximity marketing and push notification as well. The second mode we have is fingerprinting. Again, the fingerprinting approach gives you an accuracy of 3 to 7 meters in most of the cases. The pros is it's way better accurate. You've got a stable position. It's battery efficient and low cost. The cons are you need to go on site. So site service needed. You need to set up hardware and yeah, I mean, beacon batteries are still sometimes an issue. So the use case or the usage of this technology is really to use it for indoor positioning and wayfinding use cases. Next technology I want to talk about, and I could ramble on about all of the technologies, is camera-based. The camera-based technologies are around 1 meter type of accuracy. The pros are it's super accurate and it can be combined with AR. The cons are, well, you need to set it up. You need to set up a what people call in the camera space or in this space a so-called point cloud. So it relies on type of landmarks that are pre-registered. In order to use the system, the camera has to be active, which might exclude this technology from a couple of use cases, and it's quite battery intensive. The usage of and the use case usage of this technology we see right now is more or less industrial use cases where you've got ruggedized phones and ruggedized hardware anyways, and not a standard smartphone. One of the last technologies I talked about is VLC, the visual light communication. So it's your light that's in that case not an iBeacon but a pulsated light. And you get an accuracy of sub-meter easily. So the pros are it's really accurate, and it just and it might be already installed in your building. So if you've got smart lighting, you probably already done the biggest invest in order to use this technology. The cons are here that in order to replace all your lighting and all your luminaires, this might be a high investment cost due to the special hardware that's needed. As well as if you use the technology, it's kind of battery intense on the smart devices itself. The usage we see for this technology is the indoor space. So precise indoor positioning and wayfinding where accuracy really matters. The last technology I want to talk about is our ultra wideband or UWB. It's where accuracy really matters, and it's mostly used for industrial use cases for asset tracking. So accuracy and this, which is the highest pros. The cons are it's a high cost and yeah, somehow limited use cases because you can't nowadays not use it on a smartphone because there is no sensor for it, type of thing. But again, for asset tracking, indoor and outdoor, ultra wideband is really from my personal perspective, the use case you should go for. So now after talking like all about these different IPS and technologies, I want to show you how ArcGIS Indoors actually fits into this. So the standard indoor positioning system provided by Esri is based on Bluetooth Low Energy BLE, the iBeacons I was just showing before, technology combined with sensor fusion smart algorithms. This way, well, unpredictable levels of accuracy and stability can be achieved. So we not only use the BLE, we also use Wi-Fi, and we also use GPS for those use cases where it's about to change between buildings. So basically, the ArcGIS Indoors positioning systems works in that way that it takes care of the IPS inputs and gives the users the best localization possible. Like, and I'm really sorry for this old-fashioned term, so like a middleware for indoor positioning. So you can think about it like this: in some areas of your building, you might have an IPS provided by Wi-Fi. And in some areas of your building, or even of your campus, you might have an IPS powered by BLE. So we figure out when and where to best use which technology. So you as a user of the system, you don't have to worry about any of that. In the initial phase, we're supporting, as I was saying, IPS based on Wi-Fi and IPS based on BLE iBeacons. So these are technologies we have the most expertise in and that are rendered in highest quality results in terms of accuracy, latency, and stability, as well as costs. However, ArcGIS is designed to be flexible. It can be seen as IPS agnostic, so really meaning that it's built to support any other common IPS technologies. And to go maybe now a little bit more into details how this IPS technology actually works, I want to show you some stuff. So let's get a deeper look behind the scenes of ArcGIS Indoors IPS using Wi-Fi or beacon-based technology. So first of all, how does this technology work and how to set it up? You need to really take some radio. So this is how fingerprinting more or less works. And if you have not heard about it or if you're not familiar with it. So you need to take some radio measurements. It's kind of a survey process inside of the retrospective building you want to enable IPS in. This means an on-site engagement where data is collected. The data is then uploaded to the cloud and transferred as a radio map. So you can think a radio map as a digital, no, it's not a digital visual map, it's a digital map that your phone then can interpret it to know where it is. So this radio map is then downloaded to the smartphone or sits in the cloud where radio signals are generated. So basically what's happening is that like a target performance comparison between the radio map and the live radio data. And these results then are processed into the radio localization. So you can think about this radio localization as the absolute position we were talking about in the first case, like the GPS. If we were only relying on this data, the positioning wouldn't be that accurate or too accurate. So this is why we use the sensor data of the smartphone also into account. These data are processed in PDR, pedestrian dead reckoning, and provide information on the directions the smartphone users has moved in. Ultimately, both data streams from the radio localization and the PDR are combined in a Kalman filter, making the position results more accurate, more stable, and less latent. And again, then those trajectories give us information on the movement patterns, which can be then uploaded into the ArcGIS Indoors cloud again for further improving of the system. As the next step, I want to just quickly show you two examples on how ArcGIS Indoors IPS is used or words used for some customers that Indoors my old company is working on. So the first case is the ArcGIS IPS used at Kaleida Health. Kaleida Health is a hospital complex in upstate New York, and the technology is really used to guide patients and help their way finding the way around. It is used over 12 buildings, which really gives the unique possibility to not only use the beauty of the system indoors, but also outdoors. And it's combining both the outdoor and indoor localization. The other example I want to show you, where actually we're going to show then some videos as well, is Amtrak. So indoor navigation solution for Penn Station, New York. And the highlight is that Amtrak is really one of the busiest stations that Amtrak provides, with around 600,000 travelers per day. It features an iBeacon-based positioning, which means we got there about 400 beacons. It's used for positioning and navigation on multiple levels. So I don't know who of you are familiar with Penn Station, but it's it goes 3 stories on the ground station. So it's really complex. It has around 100 different points of interest, and it enables not only the positioning inside of the station, but directly to the platform where trains depart. So those are two of the use cases I wanted to show you, which were part of my old company, where we successfully implemented indoor positioning. And with that, I will take a small sip of the glass next to me, and actually our next poll. So which technology are you thinking about using? But
go ahead and launch that. Yep. There we go. And if you're thinking of more than one, go ahead and choose more than one answer.
Totally. Or if there is a technology you say, I want to use something special, please submit this then as a question, or please submit it later so we can follow up with you directly and talk to you about it.
Okay, let's give a few more seconds. All right, let's go ahead and close and show the results. So a lot of people Wi-Fi, which makes sense because most organizations probably already have Wi-Fi in place.
Sweet.
Yep. 65% also mentioned BLE.
Yeah.
Good beacons. Yeah.
That's really sweet. Thanks. Yeah, I mean, again, those 15% of others, I'm really interested in what type of technologies you guys want to use. Please submit this or send us a quick note later. I'm really curious to follow up with you guys on this topic.
All right.
And with that, I would like to start and talk about what's next. So to summarize, ArcGIS Indoors does support at the start BLE and Wi-Fi based indoor positioning, but what's really next? So to show you that, as I said in the initial phase, we are going to support Wi-Fi and BLE, and the plan is to really support any tier 1 IPS system out of the box. So we are looking at VLC, we are looking at geomagnetic, we are looking at some other technologies, but as we all know, there are a lot of our technologies out there. So if you see any major tier 1 IPS provider we have not talked to, or you have not seen on our slides, or you have not seen us mentioning, please let us know so we can talk to them and make you successful by automatically being able to support them using the ArcGIS Indoors system. Another thing I want to really highlight is there are and always will be IPS that have a very regional or very industry focus. And this might not be a tier 1 IPS provider seen on a global scale, but we still, or you as a user still want to use it using the ArcGIS Indoors system. If you find or if you encounter any of those possibilities where you see, I don't know, there's a tier 1 provider or there is a local or regional really strong IPS, there's always the possibility to have a custom IPS connector. So this custom IPS connector for us is something that, well, of course, we are going to support. So if you have any of those requests, please reach out to you. So services together with us can have a look at on how we can make that possible for you in your usage of ArcGIS Indoors. Again, this is just a quick look at what ArcGIS Indoors looks like from a system perspective. And as we learned before, IPS is used in the ArcGIS Indoors mobile applications to provide indoor positioning. The blue dot in the ArcGIS Indoors mobile apps for iOS and Android. But what does it mean for the whole ArcGIS Indoors product family? Well, we are working to provide these blue dot capabilities, the indoor positioning across the whole ASRI platform. Just think about field apps like Collector or Navigator. Wouldn't it be nice to use IPS in this product as well? Especially as we all know workflows don't stop at the brick and mortar walls. Not only field apps, but also other products will benefit from the possibility to be able to not only be floor aware, but also know the position within a building. So please stay tuned and we will inform you about this more during the next couple of months, as this is really where we see a lot of growth. With that, I would like to go and show you some demos. So we prepared two different demos. One is for the transport industry, one is for retail. One, the transport is at Amtrak Penn Station, and the retail is at a local shopping mall just below our Vienna office. So let me first start with the Penn Station demo. So what you can see here is you're at Penn Station and you're searching for something. Let's say you're searching for a platform. You can just flick out your phone and type in the platform you're looking for. It automatically shows you where it is. And by the way, this is a custom application that was developed for Amtrak. And then you can get yourself navigated there. So you see the dot, how the dot moves, and how the IPS is used in that type of system. So the dot continuously moves with where the person actually is and shows you your position. In about, I don't know, maybe couple of seconds, what you will see is an automatically floor change. So the system, the IPS, does not only tell the user where he is in terms of longitude, latitude, but also in terms of a set coordinate, in terms of the level you're on. So as we're approaching the track level, the position automatically changes. So now we are the destination we were looking for, and you see we are in lower level 3. So this again was a custom implementation of the IPS. Now what we're looking for is, I think we're looking for a different store, and this now goes through multiple levels. So we are now on lower level 3. Again, the IPS knows where we are. The IPS shows you where you are, and we go up the staircases, and it automatically detects not only where you're on the floor, but also on which floor, not only where you're inside of the building, but also in terms of the floor level. It automatically switches here. By the way, this IPS was provided based on iBeacons, based on BLE beacons. You see that the positioning is continuously updated. You get an update frequency of, you can actually specify, but an update frequency of around a second. And you see it smoothly follows the position someone is walking. Even though, so some of the challenges when providing an IPS is that the people are walking around all the time. So all of us are more or less, what is it, 80% water, which means that we kind of shield the position, or we kind of shield the signals the IPS, the indoor positioning, is based on, in that case, iBeacons. So now we changed to floor level 1, and the system automatically detects that and updates its position. So yeah, you get an idea on how positioning works in a big railway station. And as next, I want to show you how positioning, and this is really showing not in the next example, not in a nice environment, but in a like a debug environment, how the position works when you look at it very rawly. This is in a shopping mall, which is located in Vienna. It's one of our test beds. And what you can see here is the old Indoors app. And you can see that the position automatically changes. Again, this positioning here is based on BLE. It's based on the Bluetooth flow energy. And in that case, we're going to change floor again. And you see that the position automatically switches floor. It's maybe a little bit jumpy around in some cases because of a challenging environment and a huge open space. But as soon as we're going to go up this one floor level, you can see the floor level picker changes, and as well as the representation of the map. And with that little demos, what I would like to do now is not only start my presentation again, but go into another poll. So our next poll really is why do you want to use an IPS, and what are the use cases you see for using an IPS, and what should your project look like? Maybe Christian, you can open it up.
It is launched. You might not, I don't know if you can see it, Bern, but it's open.
Oh, sweet, thanks. So yeah, again, if other, please send us a quick note. We're really interested in what type of use cases you are interested in.
A few more seconds
so
here.
Our experts can follow up with you.
And all right, we'll go ahead and close that and share the results. So yeah, a lot of people interested in obviously mobile wayfinding, but asset tracking and analytics as well. It's great.
Yeah, it's really good for us to know what type of use cases you're interested in. So if you reach out to us, and if our experts are allowed to reach out to you, then we have already established a way of communication, so we can give you the best information you're actually looking for.
All right.
So with that, I'm going to continue and show you but it's not the most important thing. How do I get started? How do I get started with ArcGIS Indoors and usage of IPS? And there, I really want to highlight one thing. We got the Indoors pilot program. So we have set up a dedicated pilot program that enables you through a hands-off engagement with the ArcGIS Indoors team to deploy initial operating capabilities. Please reach out to an ArcGIS Indoors expert to learn more about it and get started with your project. I will show you later a link you can follow to where you can register. But if you're curious, I mean, just also shoot me a quick email or contact me on any other way. In general, how do you get started with ArcGIS Indoors? There are just 3 steps to get started. So the first one is the indoor map. It's what we call the first step. So you get your map into the digital ArcGIS Indoors maps, which then are 2D and 3D. You've got the POIs and POIs and site plans. There's a next step, and this is what we talk now a lot about, is to be able to set up the indoor wayfinding and the indoor tracking. You enable the IPS, you enable the indoor positioning, and then you run the software and set it up. You do the configuration, you do integrations, and you do extensions to the system. So really, if you need more information, and by the way, this is the end of our webinar. So if you want to learn more about the pilot program or ArcGIS Indoors in general, please get in touch with an expert via our website. Just go to go.esri.com/indoors. And at the bottom, as well as at the start of the page, you find a contact form which will put you in touch with one of our experts. If you would like to stay up to date with ArcGIS Indoors at all times, we also highly recommend you to follow our social media channels. And you can find us on YouTube, you can find us on Twitter, you can even find us on Facebook, and now even you can find us on Instagram. I personally am not an Instagram person, but I heard that it's not pretty cool to be on Instagram. So thank you for this, and
Hey, Baron,
happy to answer any questions. Yeah.
can you go ahead and go back a couple slides? We had a question.
Sure.
Just one more, I think. Yeah, let's keep it here for just a little bit so you can see it. And while we have that open, we've been seeing some questions coming in. I think one was how long it would take to get a system like this implemented.
Oh, yeah. Perfect. Yeah. So this is a good question. So how long does it take on average to implement an IPS into a building? So the implementation itself can actually be done within like weeks. So depending on the size of the building and the layout of the indoor space, so how high is the ceiling or how many obstacles are there and so on, this may vary between like 1 or a couple of weeks. From our experience and based on the usage of an IPS based on BLE beacons, a space of around 30,000 square meters, which roughly translates into 350,000 square feet. It can be done within like a couple of weeks with 2 on-site engineers.
Great. Okay, and there was another one, I believe it was about the data that's being gathered. Who does that belong to?
Yeah, that's a really good question. That's an amazing question we always get, and I think this is where the beauty of ArcGIS Indoors system stands out. The data, by the way, on the contrary to other systems, is 100% yours. So all the data you collect and you compute, it's yours.
Good. And then let's see here. What is needed from the client side to enable indoor positioning?
Great question. So in order to enable indoor positioning, what we need is, first of all, we need a precise floor plan. Not only we do need the precise floor plan to set up the ArcGIS Indoor system, we also need it for planning on how the IPS will look like and how the IPS works. So we provide really the professional services for this implementation on site and support throughout the project. Additionally to what is needed in order to enable IPS is what we like to do is kind of an assessment of what's already out there. So if there's Wi-Fi, what type of Wi-Fi? If there's beacons, what type of beacons? So also what plays well into which type of IPS to choose from is the question on what's the use case. And by the way, I'm just going to switch one slide so you can see the link to the go.esri.com/indoors. So what's the use case? So what do you want to achieve? Do you want to achieve asset tracking, or do you want to achieve mobile wayfinding? This really the use case really defines on what type of technology there can be used or there should be used, as well as how we set it up. So for instance, I was talking before about the different IPS technologies. If you're looking at the very super precise asset tracking solution, ultra wideband might be the solution you want to go for. But if you're looking for mobile wayfinding and you've got a building where nothing is installed yet, well, maybe it's easier to just place some iBeacons instead of set up a Wi-Fi, because cabling and setting up a Wi-Fi might take more time and costs. If you look at, for instance, office environments that are iOS shops only, well, then let's use the Wi-Fi. Let's use the beauty of iOS systems in order to provide you with an indoor positioning coordinate as well.
Great. I saw one more question come in, Bernd.
Yeah.
So if someone had Wi-Fi, is there any speed recommendations? Can you talk a bit about that?
Yeah, and that's a really good question. So how does Wi-Fi positioning work? Wi-Fi positioning works like this: that the speed of the Wi-Fi or the data throughput through the Wi-Fi is actually not the one that's really interesting for us. For us, what's really interesting is the density of the Wi-Fi, as well as if there are some additional setups enabled, like dynamic change of how strong the Wi-Fi signal sends out. So there are some systems in place where, for instance, I don't know if in the room I'm sitting now in, there are sitting 5 people, then the Wi-Fi access points automatically detects that and kind of sends stronger signals to that room. If those features are enabled, we might have some challenges, but other than that, basically, if it's a standard Wi-Fi installation, in most of the cases, we can just run with it and use it. So speed is really not the limiting factor or the one we primarily look at when setting up an indoor positioning system.
Great, thank you, Bernd.
Sure.
We're seeing dozens of questions continue to come in, so I think right now would be a good stopping point. We are tracking all your questions, and we will continue to take them all in and answer them after this. This webinar is being recorded, so you will get that shared with you probably tomorrow. And also, we will share the slide deck with you, because I saw other people asking to go back to slides, so we'll share that with you as well, so you can review it at your own leisure. But other than that, we thank you all for attending today. We will answer these questions, as I said, and we hope to see you next time. Thank you.
Perfect. Thanks, everyone.